Hello, I'm Lewis and I'm going to show you how to build your very own 3D printable double helix wireless Qi charger. A Qi compatible wireless charger is embedded in the top of the housing, so you can easily charge any Qi enabled devices. Underneath this is a slowly rotating glow in the dark double helix. Two blacklight LEDs pulse gently to charge the double helix before allowing it to glow as the LEDs fade off again. Two recessed switches on the underside of the overhang allow you to enable and disable the LEDs or motor separately. The whole assembly is powered by a single USB connection. If you would like to build one of your own, then you can order a kit which contains everything you need except for the 3D printed components. You can of course download both the files for 3D printing and the code to run on your Arduino from this project's page at electromaker.io. Just follow the link up here in the corner or have a look in the description down below. The kit contains a Qi wireless charger, some LEDs, an Arduino Nano Every board, a USB Type A male plug, a USB Micro B plug, a stepper motor driver board, and a mini stepper motor. Some 100 ohms resistors, a couple of sliding switches, some lengths of grey and white wire, 8 M3x6 screws, and a USB-A to Micro B cable. There are also 8 parts to this project which you will need to 3D print yourself. I printed all of mine in PLA in a shade known as Gentleman's Grey, except for the double helix itself. The double helix was printed in 2 different filaments. Gentleman's Grey PLA was used for the lower layers, and then some glow-in-the-dark PLA filament was used for the rest. This was achieved by changing the filament partway through the print. On a Prusa printer, this can be done by going to Tune and then selecting Change Filament whilst the print is in progress. Alternatively, you can program a color change while slicing the STL file in Prusa Slicer. We'll kick off the assembly by installing the Qi transmitter into the 3D printed top housing. The top housing file was printed without any supports or brim. My print took about 7 hours at a 0.2mm layer height, and I used about 23 meters of filament. Position the coil face down into its holder and apply some small dabs of hot melt glue to keep it in place. Once this is cooled, you can carefully fold the circuit board back over the coils plate and hold this into position using 2 of the M3x6 screws. Just be careful not to over tighten these. Now we'll create our own mini USB cable by preparing 2 13cm lengths of wire. On the Type A plug, the larger of the 2, the grey wire should be soldered to the leftmost pin when looking at it with the connector pointing away from us, whilst the white wire is soldered to the rightmost pin. We can then finish assembling this end by push fitting the top of the connector onto the bottom half. At the other end of these wires, we will attach the micro USB connector. Before soldering, thread both the wires through the small sleeve. Now again, with the plug facing away from us, and with the side with 3 pins facing upwards, the grey wire should be connected to the left hand side, and the white wire to the right hand side. You can now slide the collar up the wire, and assemble the housing of the Micro B connector. For the motor, we will require 5 40cm lengths of wire. Solder one end of each to the following pinpoints on the motor driver board: ground, B out 1 and 2, A out 1 and 2, You should label the other end of each wire so that later we can easily identify which wire was connected to which pin. Solder a 12cm length of wire to the positive side of V motor. The other end is soldered to an outside leg of one of our switches. To the centre leg on this switch, attach a new 12cm length of wire and connect the other end of this to the VIN pin on the Arduino. Solder a 20cm length of wire between the motor driver's negative side of V motor and a ground pin on the Arduino. Let's begin to assemble the base. For this, you're going to need a few more of our 3D printed components. Base housing.stl. This was a 7-hour print at 0.15mm on my Prusa Mark III's. If you have problems with print bed adhesion, try adding a brim, and there is no need for supports. Motor topplate.stl. This part took just over 3¼ hours to print at a 0.2mm layer height. You will need to enable supports for this part. Joiner.stl. This part is used to help align the prints as we assemble them later. I printed mine at a 0.15mm layer height, and this took about 1 hour and 10 minutes to print. I also printed mine with a brim. You will also need the small stepper motor for this stage. We'll begin by gluing this in place into the motor top plate. Ensure this is level as the glue cools by pushing it right up against the print. Add some additional glue to ensure that this does not come loose later. Now we can add some glue to the underside of the rim on the base housing print, and then we'll insert the motor and its plate from beneath. Again, hold firmly in place whilst the glue cools and sets. Now use a small dab of glue to insert the joiner. The long end is inserted downwards until it touches the table. Its shape will ensure automatically that it's aligned so as not to block any of the cable runs which we will be using later. This sub-assembly can now be put to one side and we'll carry on with our electronics. Prepare two 10cm lengths of wire and shorten the legs on both sides of the two 100 ohm resistors. Solder one wire to one resistor and repeat with the other. Solder one of these wires to digital 9 and the other to digital 10 on the Arduino. Trim a third off the length from the legs of two LEDs. Ensure that you maintain the fact that the anode leg is the longer one. To the other end of the two resistors, solder the longer anode leg of an LED to each. Now prepare a 12cm length of wire and a 5cm length. Solder these to the two unconnected legs of the LEDs. Both of these wires should then be soldered to the same outside leg of one of our switches. We then attach an additional 10cm wire to the centre leg of this switch, which is then connected to ground on the Arduino. Before we begin to install the electronics inside of the housing, we'll connect our Arduino to our PC and upload the code that's required for this project. To do this, use the provided USB cable to connect it to your PC and open the code for this project in the Arduino IDE. You can find the code for this project on the projects page at electromaker.io. If you have not used the Arduino Nano Every before, we will need to install a new board type into your IDE. To do this, open the Tools menu, select Boards, and then Boards Manager. In the Board Manager that pops up, search for Mega AVR and install the latest version. Now check the board type of Arduino Nano Every is selected in the Tools menu, as well as the correct serial device in the Port section of the Tools menu. We can now upload the code to the Arduino. As long as the upload is successful and your wiring so far is correct, then you should see the LEDs start to slowly pulse. If you don't see this, try the switch connected between the LEDs and ground on the Arduino. We're now going to install a lot more of our electronics inside of this housing. Don't worry if you can't make it fit the same way I have. You may find an alternative layout which will work better for you. We're going to start by taking the small USB cable we made earlier and connecting it between the Qi charger and our Arduino Nano Every board. Next, I'm going to take the LED with the longer wire going to the switch and glue it into place on this pillar facing straight upwards. You can bend the legs of the LED apart slightly to help prevent them from short circuiting. The other LED is to be fixed to the remaining pillar at an angle. Now the switch that controls these LEDs is glued into place at the top of this U-shaped column. Make sure the switch face is flush with the top of the column and that any glue does not interfere with the operation of the switch itself. Now prepare 5 18cm long lengths of wire and solder one end of each to the following points on the motor driver: A in 1 and 2, SLP, B in 1 and 2. Then we'll connect the wire from A in 1 to D5, A in 2 to D4, B in 1 to D6, B in 2 to D7, and SLP to 3.3 volts on the Arduino. Apply a generous helping of hot melt glue to the rear side of the Arduino and fix this against the side wall of the housing. Glue the remaining switch to the unused switch holder. Again, make sure it is flush with the top of the column. The motor driver board is then also glued into place. Now that we're towards the end of our project, you're going to see a lot of progress happen very quickly. For this next section, you'll need 2 more 3D prints, the spine and top cover. You'll also need 2 of your screws and the USB cable. The spine took just under 14 hours at a 0.15mm layer height. I used a large brim to help this adhere to the print bed, as it's quite a tall print. The top cover took 1 hour 17 at a 0.2mm layer height. Connect the USB cable to the Qi charger and route this cable through the outlet at the rear of the top housing. Place the unconnected stepper motors from the motor driver alongside this USB cable. The top cover can then be screwed into place using 2 of the M3x6 screws. Now thread the USB cable and stepper wires through the tunnel in the spine and fit the spine onto the top housing. Thread the same items through the hole in the rear of the bottom housing and sit this into place on the spine. To connect the stepper motor, remove the plug and strip back the wires. These then need to be soldered together as follows: red to ground, pink to A out 2, yellow to B out 2, orange to A out 1, and blue to B out 1. Wrap some insulation around these wires so that they can't shorten the circuit, and we can then add the bottom cover. Secure this in place with 4 M3 screws. To help reduce noise from vibrations, cut 3 small lengths of rubber band and glue them onto the feet. The glow-in-the-dark double helix that we printed earlier is added simply by aligning the hole with the shaft of the stepper motor and lowering it into place. As long as it is well balanced, the only part this print should make contact with is the stepper motor. You can also add a few small dabs of superglue to help keep the spine in alignment with the top and bottom housings. If you've enjoyed this project, then why not take a look at some of the others available on electromaker.io, such as this disco helmet. If you need the electronics to build one of these for yourself, then you'll find a link to where you can purchase all of the parts on the projects page at Electromaker. Thanks for watching. Until next time, ciao for now.